Good morning, everyone. I really appreciate you being here on a Sunday morning, having lost an hour of sleep. My name is Nathan Selikoff, and I am a data visualization and user interface engineer working at Stitch Fix. Stitch Fix, you might know, is a clothing company. We are an online personal styling service, and we adapt to your changing needs and tastes and preferences. We do this with a combination of algorithms from data scientists and the artistic expertise of human stylists. Those things are combined by the work of designers, designing algorithmically driven experiences, whether we're talking about your fix, which is a curated box of 5 items shipped to you, or your own personal shopping feed, which is an experience we call freestyle. This all comes together with a mix of art and science. So I'm going to talk to you about how I got to Stitch Fix, and then how we combine art and science at Stitch Fix to solve real-world problems. So I am both an artist and a programmer. And that juxtaposition sometimes surprises people, but probably a little less surprising at South by Southwest. And maybe even a little less surprising when I tell you that my mom is an artist and my dad is an engineer and a musician. So it was almost inevitable that growing up in that environment, I would be drawn into art and technology. And it started really young. The computer that graced our desk in 1986, 87 was a Commodore 64. I was 6 or 7 years old at the time. This very computer, actually, I had it up until last year. And this computer was magical. It had a mouse, it had joysticks, it even had a drawing tablet with a stylus, believe it or not. And when you turn it on, you would see this blue screen. Not the blue screen of death of Windows fame, but this open kind of blue sky screen of possibility with this little blinking cursor, which I always thought of as like the pulse of possibility. It was just beckoning you to start typing something into the computer. And so when I was a kid, one of my favorite things to do was to flip to the back of this magazine called 321 Contacts, which had a program written in the basic programming language, which was a very easy to understand language. Now at the time, 6 or 7 years old, I didn't really know what was going on, but if I very carefully typed in all of the characters from this program, line by line, and got to the end and didn't make any mistakes, and hit run, then some game or picture or a little interactive experience would happen on the screen. And this was empowering, and it was exciting to me. And I was starting to learn this language of programming, and this language was shaping my expression as well at the same time. And art and algorithms was coexisting in this place of computation for me. And there were some early seeds of mathematics as well. I remember another beginner programming language called Logo with a little triangle on the screen called the turtle. And you would tell the turtle to move forward 10 steps, and then maybe if you were trying to draw like a star, you would say turn right, 288 degrees, and then repeat that 5 times. And oh, well, that's actually a hexagon, not a star. Like, what was that angle again? So that combination of wanting to make things happen on the screen and mathematics and programming really continued to draw me in. So as time went on, I found other sources of inspiration. My dad gave me this amazing book called Artist and Computer. It was published in 1976, and it has all these beautiful black and white computational drawings from artists like Vera Molnar and Lillian Schwartz, pictured here. This generation of artists had been working in places like Bell Labs in the 60s, side by side with engineers, exploring a new type of computational media and exploring what the affordances of that media was for artists. In terms of the art movements that were associated with this kind of work, you could think of this as being connected to conceptual art, where the idea of the piece took center stage as opposed to the actual hand of the artist. So for example, Vera Molnar, one of the artists working in this medium, said, "In order to process my research series in a systematic way, I initially applied a technique I called machine imaginaire. I imagined I had a computer. I created a program, and then step by step, I realized simple, limited series which were self-contained and thus did not skip any shape combinations." Now keep in mind, she started this work in the late 1950s, and she was imagining a computer in her head even before she got into this setting of Bell Labs where she had engineers and computers available to her. Another one of my favorite artists from this era, Sala Witt, wrote about conceptual art that the idea or the concept is the most important aspect of the work. The idea becomes a machine that makes the art. This kind of art is not theoretical or illustrative of theories, it is intuitive. And this mix of intuition and imagination and mathematics and computation continued to draw me in. I played with 3D computer graphics. I started to learn graphics programming. I found more artists online, artists like Jared Tarbell and Jer Thorpe. I was exposed to mathematical ideas about fractals and chaos and strange attractors through interesting authors like Clifford Pickover. And in all of this work, artists and others were sharing their algorithms. There was a programming language called processing that was developed at MIT. It was freely available online, and it was really designed for artists to create computational work. And the kind of work that was made was often shared online with the source code and everything. So it really fostered an environment where folks were sharing their source code, but also their algorithms, and it helped me learn a lot. So I felt like I was in good company with artists working with computers. Although entering college, I didn't exactly know where I belonged. I started in computer science, I switched to digital media, I eventually switched over to fine art, specializing in computer animation. And part of that was just kind of getting around some of the bureaucratic barriers from artists or from students not being able to take classes that were not in their major. And there was a little friction when I started creating my work after college and looking for places to show it as well. At the time that I was getting started, the kind of group shows that a lot of artists cut their teeth on were explicitly excluding digital prints. So this was, you know, the art, capital A art world is a little bit slow to take on new media, and I experienced that as well, but eventually found places to show my work, places like Los Angeles Center for Digital Art and SIGGRAPH Art Gallery and the Bridges Math and Art exhibit. And even though it was hard to classify, people would ask, you know, is this art? Is it math? Is it math art? Is it generative? Is it algorithmic? You know, eventually found some homes. So I'll play a video for you to show you some of the pieces that I did from 2011 to 2015.
as I'm talking, the hour and the minute hand are vibrating based on how I talk. So I'm watching sound is basically what I'm doing right now, which is pretty amazing.
Sometimes it could like show stars in the wall, and surroundings, like you can put in the kid room.
By the way, if you're curious about any of those pieces, I'm happy to talk your ear off about those later. But in 2013, I started really getting into maps. And I'd always been into maps, old hand-drawn maps with those really careful contour lines around the shorelines, the really old maps with "Here be dragons" in the unexplored territories, at least in the minds of the map maker, and even the MapQuest maps that we used to print out before ubiquitous GPS and smartphones. But I really got into them when I started engaging with public transportation. And this happened when a few friends of mine put together a public art intervention called the Transit Interpretation Project, or TRIP for short. My friends David Thomas Moran and Pat Green put this together, and they bought a 30-day bus pass and gave it to a different artist in Orlando every day of the month. So an artist would take the pass, they would ride the bus, and they would do something based on that experience and then hand that bus pass on to the next artist. So I participated in this project, and it had been a while since I had ridden the bus. I'd ridden it a few times. And during my trip, it took a while. It took probably 4 or 5 times longer to get where I was going, the coffee shop, than it would normally take if I drove. And I started thinking about the structure in the system. Like, why are the routes designed this way? Like, why do I have to go all the way to the center station and then all the way back out just to go like sideways a couple miles to the coffee shop? And where can I learn more about these decisions and this data? How can I start to wrap my mind around this? Some of the other artists, they created photographs, short films, blog posts. Somebody even created a dress with the bus route stitched into it. I ended up creating this piece called "Searching for the Flow of the Tropical City." So it turns out that there's a data format shared between companies like Google and transit systems that encodes the schedule. And so I was able to get my hands on that data, which is publicly available, and use it to create an animation of the buses moving across the city and in and out of the central station. And the title comes from one of those other artists, Richard Reep, whose blog post was called "Searching for the Soul of the Tropical City." And he writes about our central transit station as the heart chamber of the city, the place where all the blood condenses and is forced through valves into the arteries and veins of the town. So the outgoing buses in my piece are colored red as if they were blood with oxygen in it going out of the central station, and then blue as if it's deoxygenated blood coming back through the veins. So getting my hands on that data answered some of my questions, but it raised a lot more. The seeds had been planted, though. I wanted to get engaged more with public transportation and make it a more viable option for getting around in Orlando. Over the next couple years, one of the projects I worked on was called Local Notebooks, and I took that same data and designed maps that were kind of centered around public transportation routes and emphasized those over the road grid instead of the road grid, and etched those onto notebooks and sold those around town. But the seeds really kind of germinated and pushed up out of the ground when I took 2 months to travel in 2016 and came back to Orlando with a bevy of new experiences from Nepal to Norway, and was kind of thinking about all the ways that I'd observed that transportation and access had impacted people's lives. So coming back to Orlando, I wanted to use my skills and experience to try and make a difference on the bus. So being an artist and a programmer immersed in technology, for better or for worse, I'm always thinking about kind of technological solutions and how I can leverage the power of computation to try and solve problems. So I joined up with David, who had started the Trip project, and we started a company called Omnimodal to try and deal with some of these issues. And my friend Myra's experience, she's here, I'm here walking alongside of her, was pretty typical. She would commute via bus to work every day, and it would take about 3 hours to go less than 10 miles. If she had one shift, you know, if she had 2 shifts, then it was double that. And it was exacerbated by the fact that there was no real-time data for the bus. So she didn't know if the bus was running early or late. And with routes, many routes in Orlando only running every 30 minutes or every hour, you know, if you really want to get there and not miss your bus, it's a lot of extra time. So that's where we started with Omnimodal in terms of looking at real time. So real quick, I want to return back to this and talk about it. So, you know, this kind of gives the sense that the system is running smoothly and efficiently, and everything is on time, and it's a sped up 24-hour cycle. So it's like, oh, everything's great. And you could think of that as like a vision for what transportation could be in a city like Orlando. From a different perspective, maybe that's more of an erasure. You know, if you think about the sidewalks are not there, the train is not there, the buses that break down and run early and late are not there. But it's a data visualization. It's an exploratory data visualization. And it had some power to create some shared intuition for David and I and folks that we were starting to talk to about this transit data and what we might be able to do with it. In addition to helping get real-time data flowing on some of the local transit networks, we started to bring in transit data from bikes and scooters, from smart parking, all into a central dashboard that city staff could use for daily operations and for planning. And just this act of bringing this data into one place was really powerful, because it turns out that the folks that kind of manage the downtown circulator are different from the folks that manage the contracts with Lyft and other micromobility providers, who are different from the folks that manage traffic and parking and special events. So bringing this all into one place, you know, provided some kind of level of cross-departmental collaboration and building trust and letting people start to see like how these things interact. Hey, if all these bikes and scooters are ending up in this particular area and we don't really have a good bus route that's kind of circulating from that area, maybe that's something we need to consider. I worked on this startup for about 4 years and didn't realize it at the time, but I was kind of data science adjacent. So I'd implemented some open source things that were machine learning models for predicting arrival times. I'll talk a little later about what machine learning model means. And you know, built a lot of data pipelines to get this data into one place. But we had really just begun to scratch the surface of things like trying to visualize mode share, which is what you see on the screen here, which is a little bit of a wonky term, but it's when people stop using one form of transit and use a different one instead. And it's really what cities want to optimize. You know, they want folks to get out of personal vehicles and onto shared bikes and scooters and onto buses and trains. So eventually, when I was kind of done working on that, I came across Stitch Fix, which was an exciting opportunity because I was going to be able to be very close to data science and a much more well-resourced team. As I briefly mentioned at the beginning, Stitch Fix is an online personal styling service, and it evolves with your taste and your needs and your lifestyle. And behind the scenes, we do this with a combination of art and science. And this is a really close collaborative role between art and science across a lot of different folks within the organization. And every role at Stitch Fix kind of has an aspect of art to it and an aspect of science to it. Specifically, I work in the algorithms department, which has about 150 data scientists and data engineers working on optimizing all parts of the business. So I saw some eyebrows raised. Yes, that was 150. That's a lot of data scientists. It's a lot of data science. There's a lot of interesting problems to solve at a company of this scale, from what to buy, how much of it to buy, where to stock it, how to most efficiently ship it, how to personalize what we show you, how to personalize our marketing materials. There's really a lot to do, and we have this little animations from our algorithms tour, which is on our tech blog called Multithreaded, so I definitely recommend checking that out. It's like a little data viz scrolly telling thing where you can see all the different parts of the departments. So I work on a small team within the algorithms department called Algo UI, or Algo User Interface. And we work very closely with all these different data science teams to make their work more tangible and visible across the rest of the company. So for us to be really good at this, we have to be good user experience designers, good graphic designers, good programmers, very good communicators, very comfortable with data, and we have to start to learn the language of data science, of engineering, of product development, and then depending on what project we're working on, might get into finance and marketing and PR and just kind of all those different aspects of the business. So my manager shared a concept with me recently that kind of resonated with the way that the things that we build, like data visualizations and internal web apps and tools, and our team itself is kind of like a bridge builder between these different parts of the company. And that concept is called a boundary object. According to sociologist Susan Lee Starr, a boundary object is information, such as specimens, field notes, and maps, used in different ways by different communities for collaborative work. And there's a closely related metaphor called a trading zone, which is applied to collaborations in science and technology. Peter Gallison, an American historian and philosopher of science, wrote, "Two groups can agree on rules of exchange even if they ascribe utterly different significance to the objects being exchanged. They may even disagree on the meaning of the exchange process itself. Nonetheless, the trading partners can hammer out a local coordination despite vast global differences." So I've just started learning about these concepts, but kind of in my own words, the way I would describe it is that we have this boundary object or this trading zone that sits in the middle of all the different parties that are doing collaborative work. Since every different community has different ways of talking about things, thinking about things, different goals, but they're doing this kind of shared work, they need that kind of shared space in the middle to be able to collaborate, even if the way that they use whatever that shared thing is, like a data visualization or a web app, even if they use it differently and ascribe different kind of meaning and importance to it, it serves as that bridge. And some examples that kind of relate to the things I've been talking about. So a programming language you could think of as a boundary object between the programmer and the machine. So the programmer is expressing intent by writing in the programming language. The machine is using that language to create executable code that can actually run on hardware. And you can also think about an algorithm. So in the context of the artist that I mentioned earlier, the artist is expressing some kind of design or concept through their algorithm that might be executed by somebody else or a computer or even the artist themselves, but in a different frame of mind where they're not thinking about the concept, then they're just thinking about the execution. And for a data scientist, they are developing algorithms and they obviously have to have a pretty deep understanding of the algorithm itself, but that's different than the engineer who has to implement the algorithm and needs to know, okay, how am I gonna call it? How am I gonna use it? What are the error scenarios? How performance is it? And that's different than the product designer, which just needs to know at a higher level, like what are the capabilities afforded by this particular algorithm? And also what happens when it goes wrong, right? And then thinking about a transit map is a really good example of this boundary object used in different ways. Riders use it, obviously, to get from point A to point B, figure out where you're gonna pick up the bus. The city staff use it for planning across different modes of transportation. The transit operators themselves are using it to balance coverage and frequency. And then maybe like an activist would use a transit map to kind of point out the areas of the city that are not covered by transit very well. And then finally, data visualization is a boundary object as well. So the data visualization designer is taking this information and data and distilling it down into a form that's more digestible. And then whoever that data visualization is designed for is consuming that information, hopefully enabling them to do some action based on it. But then you could also think of governments using data visualization to influence, or companies using data visualization to try and distill complex ideas into more digestible forms for marketing, like AWS's advertisements at the Super Bowl. My team, the things we create are also boundary objects, and I've mentioned a few examples here. I want to dig in a little bit to the dynamic specifically between data science and engineering and product development. And by the way, in design, I'm just kind of lumping in user interface design, user experience research and design, product management, kind of all those things. Think of under the umbrella of design. In the not so distant past, most tech companies were developing their software with engineers and designers. But in the last decade or so, machine learning has become like an important differentiator for companies to be able to deploy things at scale that are more uniquely personalized to individual users. Stitch Fix obviously does this, and the algorithmically driven experiences that utilize the work of data science are enabled in part by machine learning models. So just let's unpack some of this lingo here. So let's think about an example that you're all familiar with as users, even if you don't necessarily know it. Recommendation systems are used in things like TikTok, YouTube, Netflix. So when you open up Netflix and it says, because you watched this movie, we think you would also like these other movies, that's part of a recommendation system. Think also of your Twitter feed or your Facebook feed or Instagram. Long gone are the days, well, you might be able to get there, but it's hard to get your feed to actually show up in just chronological order of all the things of all the people that you subscribe to, right? So overall, what a recommendation system is doing is like looking at the entire universe of things that could be shown to that user and figuring out what are the best things, that small curated list, to show to that user at that given time. Digging in a little bit more, underlying the recommendation systems is usually this question of like, what should I show this particular user at this particular time out of the entire universe of stuff that I have in order to maximize some business objective? And there's a lot of predictions and probabilities that factor into answering this question. And somewhere in the mix is usually this thing called a machine learning model. A machine learning model has, I'm going to say another sentence with a bunch of lingo and then we'll unpack it again. It's been trained with historical data in order to answer this kind of question about future behavior. Really what this means is that we take a bunch of old historical data and we feed it into this black box, which we'll continue to dig into a little bit. And the algorithm or the model learns how to answer that particular question based on the old data, so that when we feed it new data, it can give us some kind of answer. So it's still a little bit mysterious, but we're going to keep on digging in here. So to break it down a little bit more and make it a little more tangible, we're going to look at an algorithm that we utilize at Stitch Fix called Latent Style. Latent Style helps us understand your style preferences and also helps us understand the style of our merchandise. And it starts with a game of sorts called Style Shuffle that you'll see if you are a client or if you open up our app or website. And we show you a series of clothing items and we ask you, would you wear this? And you thumbs up or thumbs down. So with that little game, we've collected billions of ratings from millions of clients over time. And that serves as that historical data that is passed into the algorithm that the algorithm is trained on. And the algorithm is trained to answer one question at its core, which is, will this particular client like this particular item? And it gives a probability for that. So for example, we could ask it, will I like this pair of brown pants? And it will say, this is actual data, by the way, 99.9% chance yes. And in fact, I think I own this pair of pants from Stitch Fix that's on the screen. And you could ask it, will Nathan like this polo jacket? And it will say 1.5% chance. That's a pretty solid no. And you could probably guess by what I'm wearing today, you might not picture me in that jacket. I would never wear that jacket. So it's really good. It's really quite powerful. And what does it help us do? It helps us curate those 5 items that might be in your fix. It helps us personalize your shopping feed. It also helps us match you with the best stylist for you. It also helps us personalize our marketing so that when you get an email from us, it's showing you stuff that matches your style. And it helps us show you similar items. So if you like a given jacket or dress or pair of shoes, we can show you other things that are similar to it. I've been drawing latent style as this black box because oftentimes when we talk about machine learning, artificial intelligence, models like this, we talk about them as a black box because they're hard to understand. It's sometimes even impossible to know what's going on inside that model to make it answer the question one way or another. But this question of like, how can we start to open that black box up and start to understand it a little bit more has been occupying me lately. And that could be a whole talk in and of itself. If you're interested in this, I would definitely recommend you check out the Machine Learning and UX Meetup, or MLUX for short. I've tuned into that a couple times, and it's a great space to talk about this. But we're gonna keep going and see if we can open up that black box a little bit more and develop some intuition around it. Why do we call it latent style? Well, one reason is because this particular algorithm is based on this implicit data. So I showed you style shuffle. We show you an item of clothing and say, yeah, I'd wear that, or no, I wouldn't wear that. I'm not asking you, the algorithm is not asking you specifically, like, what colors do you like? What textures do you like? What patterns do you like? What cuts of dresses do you like? So it's an implicit understanding versus an explicit understanding. And then the other reason that it's called latent, and this is, by the way, pretty common across recommender systems, whether you're thinking about clothing or movies or tweets or anything like that, is that as the model gets trained, it learns something called a latent space. So at Stitch Fix, we call that the latent style space. And we're gonna dig in a little and try and create some images in our minds about what a latent space is. So we'll start with these dots. Imagine that the 2 blue dots are 2 clients. One is me, one is you. And then all the little pink dots are different items that we sell. So in a latent space, things can be near each other or they can be far from each other. And if they are near each other, there's something that's similar about them. And if they're far, there's something that's dissimilar about them. Now let's layer on a coordinate system and start to think about this as a map. So every item that we sell, every client that interacts with us has coordinates in this latent style space. So once we have coordinates, we can think about navigating through all of the items and navigating through the clients and learning things about them. One thing to note is that all these sketches are 2-dimensional, but most latent spaces are higher dimensions. So they could be 10s, they could be hundreds of different dimensions. And the implications of that are we can't visualize it directly. And also there's like a lot of empty space. And the good thing about having a lot of empty space in a machine learning model is that that gives it room to kind of position everything and learn really nuanced information about whatever the subject matter is. Okay, so this next layer of intuition is a little bit more subtle. So instead of just thinking about like the spatial arrangement between me and you in this latent space, we actually look at the direction that things are facing. So if I was like, I've drawn the lines here to all these dots, if I'm like facing this direction, basically all the items that are also facing in that direction are gonna score high for me, and all the items that are facing in the opposite direction are gonna score low for me. So that pair of brown pants would kind of conceptually be in that upper right quadrant, and the jacket would be like on the other side. And then finally, we can add some clusters. So as things move near each other in latent space, it turns out that the shoes get close to the shoes, and the tops get close to the tops, and the dresses get close to the dresses. And so we can start to draw lines around those and understand them as clusters. So I did mention that it's impossible to visualize directly, but I like a challenge. And it turns out that there's a technique called dimensional reduction where you can go from those many dimensions down to a smaller number like 3 so that we can actually show it on the screen. And I've been doing this with an internal app called Thistle, which visualizes our latent style space as a galaxy. And so every cluster in this galaxy is a cluster of items of clothing that we've sold. This screen recording is of the cluster of tops. The cluster of tops is really big. I think it has 65,000 or so different tops, and this is just in the women's business line. But it's not just like one big blob. There's quite a bit of structure to the blob. So all these little kind of promontories where you've got different areas of density versus sparseness, or where things kind of stretch out to the outer edges, you'll see different types of tops, you know, cardigans, blouses, things that are boho, things that are very, you know, kind of classic, all these different style. This is all coming out of the latent style model that's been fed all of those style shuffle responses and has learned something about the style. What exactly has it learned? It is a little gooey. You know, it's a little hard to understand. It's still kind of mathematical and esoteric, but by starting to bring this into something visual, we're creating, my hope at least is that we're creating this boundary object and like giving something tangible that people can start to create their own mental models around. For example, I was talking to a product designer who's working on personalized search, and she said that Thistle helped her kind of think more mathematically about what our capabilities are algorithmically as she was putting together, you know, very simplified kind of client-facing experiences to let people browse this style space. Or a conversation with the data scientist. She was working on kind of accelerating our pace of learning. How quickly can we learn about your style? And she had done a bunch of work analytically. She was able to come into Thistle and confirm visually that things looked the way she would expect based on what she'd been doing analytically. And then also our leadership and PR teams sometimes use Thistle to talk to investors or talk to other folks about kind of telling the story of what Stitch Fix's personalization looks like. I could go on, but hopefully you've gotten a sense that exploratory data visualization in the context of Stitch Fix or transit data or even the artwork that I showed you has some power to kind of create shared intuition and to inspire innovation. And I think this is especially applicable for those of us who are working at companies developing algorithmically driven experiences, where it's a combination of data science and algorithms and engineering and product design because of the complexity of those models, because of the importance of kind of opening up that black box, even if just a little bit, to help us design better experiences for clients. At Stitch Fix, we're tackling these challenges in unique ways, and we're hiring across algorithms and engineering and product, among other places. And I've got ways that you can contact me online. And yeah, thanks so much for your attention, and I really appreciate you being here.